Alright, so in that last video, um, like I said, I'm doing a two-part series um, on COVID-19 contact tracing in C++. And in the last video, we looked at the concept basically behind the program. Um, and I keep emphasizing that there's only two people involved. There's the person doing the contacting and the person being contacted. Now let's look at the codes. All right, let's run the program. Let's go to contact. Let's go to tree, and let's see all the traces. So this is all the these are the things. These are the people that I entered so far, and who's been in contact with who. Um, and later on, I could probably put in a feature to say, okay, find someone and find one person and then show me that person's contact only, not just everyone. I mean, that's very simple. I mean, it's not exactly very simple, but I mean, the concept of doing it should be fine. In the same way, like if I want to sort someone, I go into the person menu and I want to search one person. If I want to search somebody, let's say I want to search somebody by name, then these are the people with that set of characters in their name. All right, so our program works. I mean, it can be improved, yes. We talked about room for improvement in the last one. And again, it might seem unassuming because people are used to Android apps. That's fine. The concept, the concept is the same. The fundamental concept, and that's what I want to keep stressing. All right, let us exit our program. So essentially, let's see, where's my here? Let's look at projects. I need this. Let's just close that. Contact tracing. So I am taking information from one to these three CSV files and I'm linking them all together. All right. I was going to put another CSV file for test, but that's another, that's improvement. I had to stop myself from actually trying to improve. But I mean, essentially, it's really like building an SQL system. Excuse me. And that's what's really awesome about this program. All right. Now, in contact tracing, we're dealing with people, right? We're dealing with people. And I have a class here called person class. Now, in my person class, I have an integer, an ID, right? I have first name, last name. Now, you see, I made everything public. I can and I will put a number of these things private, but I'm just putting them public for now. Um, yeah, here I have first name, last name. These are the characteristics of the people right now. Now you have other characteristics. You can have a date of birth. But if I wanted to do date of birth, right? Think about it. You'd have, let's say my date of birth. It's let's say it's 02 10 1987. That's not my real date of birth. So don't you know. When you look at this, right? What do you see? You see integer, integer, integer. So if I wanted to build a date of birth, right? What I would need to do is to build a struct of integer, right? And then that gets tied into my person. Um, but I'm not doing that right now. Here I have that. Okay. Now this here, I'm doing some inheritance here. So this is my person node class, and it's inheriting from person. Now, what is this person node class all about? Essentially, it is a it is building a binary tree or an AVL tree. It is going to load into that AVL tree the ID, the first name, and the last name. And what am I going to do with that? Well, we'll see shortly. Um, that we can use the we can we can build a function to have a program call that function, find the data that is inside of that node, and then use the data, right? Rather than just someone just typing in numbers. A lot of times when we're in class and we see the data, the binary tree or the AVL tree and the concept of it, the concept, it's wonderful, it's great. But you have to be able to use that concept and build something that build the cargo. Basically, let's call the information. Let's call this guy here, this string that we have. If I had data board in there, that would be another piece of cargo. Whatever information I want to store in there that I want to later on pull out, find and extract. I'll think. And if you notice in my person CSV file, right? I'm incrementing. Whenever I add a person, I'm incrementing the number. So if I were to load this as a binary tree, every single thing would keep going to the right. So, and then like, we know it's going to be a linked list. So we look at the AVL tree conversion in a few. Let's see. I have that. So this is going to inherit from person. That way I could use my person first name, last name, etc. etc. This function is really, these two functions are the two functions that I'm going to use that are going to be really cool. That I think are really cool. Actually, I just got to drink something. Yeah, these two functions are the cool functions that are going to return the information. They're essentially returning the node, and then you're taking the node and you're taking the information from within that node, and you're going to use it. You're going to use it how you want to use it, right? Um, okay. This is my AVL tree balancing stuff here. Right? We're going to use this to rotate left, right, and then do a double rotation eventually, and then balance it out. Destroy tree. This is my destructor. Destroy the tree, traverse the tree, and then start destroying it. That. Person node, insert. Basic standard stuff. Just check to see if the node null, create a new node. If it is, if the ID is that you're passing here, if this ID is larger, just send it to the right. Excuse me. If the ID is greater, actually I should put another part here that just says if it is thing to call duplicate not allowed, but I'll just leave that out for now. This is just gonna, this is what the client is gonna use, the client code to add a node. If node is not, then you go all the way there, go move all the way to the left, then to the right, and then you start deleting. Alright. It's simply just traversal. Actually, I deleted something. I deleted a piece of code. I was supposed to have delete here. Alright, fix that later. But it's basically just traversing towards all the way to the end of the end of the tree and start deleting from the end of the tree. Um, that. Print order. This is going to, if I wanted to print, but I'm not even using these, so I'm not gonna worry too much about these part. Okay, so the AVL tree balancing. Here I'm gonna calculate the height of the tree. All right, this particular code here, calculate the height of the tree, and then pass it back as an integer. Here I'm gonna calculate the difference between the two, and then I'm gonna pass it back as an integer. Right? Here I'm going to do a rotation. Then I'm doing another set of rotation. And in order to explain this rotation, I mean we did this in class, right? The left rotation, left right rotation. Let me see. So this is a right notation. So a right rotation would be just a right, pulling it down to the right, or single rotation. Left rotation, that. Left right rotation, and then this is just going to balance it out. This piece of code here, this is the code to return the node for the for return a node of person, and I'll show you where I'm using that in a few minutes. Actually, I'll show you where I'm using that right now. Now, in the last video, this is an interesting kind of a tree, right? You see, this tree has a node with 3 pieces, like a binary tree, left and right, but it has a center. Now, if it is equal, right? If it is equal, when I'm inserting here, if it is not equal, if here is left, this is going to go left, go right. But if it is equal, go straight down the center. So if the ID, so let me show you here. Let me show you here how it's going to work. So when I come to this contact, it's going to pull from contacts. It's going to pull from this file. So you see here, right? It's going to check this force number. It's going to check this force number, right? If the node is not there, it's going to create a new node. Then it's going to come in and it's going to check this number here again. If this number is the same as this number, right? Send it down the center. Same thing here. So it's going to send this down the center. Here, it's greater, so it's going to go to the right. Here, this one's greater than this one, but at this point, it's going to balance itself out. So 2 now comes to the top eventually, and 3 is going to be to the right, and 1 is going to be to the left. Now here I have a 1 again. So it's going to come to this group here and go straight down the center again. Here, let me show you. So 1 is my name, and let's just run the contact. Tree contact, show all traces. Here, so like my name is here, right? And I have 1, 2, 3, 4, 5. I have 5 contacts. So I have 1, 2, 3, 4, 5 contacts. Alright? Now who are those contacts? They are here. They are, let's see if it's giving me the right thing. Here I have it open. Person and contacts. So I made contact with person 2, that's new person. Person 3, that's Amika. Person 4, all person. This is the person I made contact with. And remember, I keep saying it's fundamentally only two people. So I made contact with this guy and this guy. So one, two. So I made two, three, four, right? And then I made contact with five, and I made contact with nine. So uppercase, those persons there. And then when I look here, you see, I have from class, that's nine, uppercase, that's five, Omega, that's three, and new person. And that's that. That's how you bridge, that's how you can bridge this gap using your classes. So it's really, really cool if you, once you have that appreciation for building classes. All right. So it's sending that information down the middle when that's equal. Um, Print order here. So here, this is what's printing that information. So let me show you this. Let me show you so that you know that I'm not messing around with you. Code I'm here. And another thing when you're building your program, right? So I had the program crash on me while I was building it, and it didn't give me a compile error, but as I was using it, it crashed. So if you want, if you can have an idea as to where it might crash, and then what you do is you just do a count, and you can say I am here. Like Horton here's a who, I am here, and, right? And if I just close this, right, rebuild, and then so if I do tree for contacts, two to show all traces, you see, called I am here. So this is the piece of code that is printing that data. Okay. See, this was the destroy tree. Oh wait, I still didn't put that freaking delete in here either. I gotta put that delete in there as well to destroy that tree. And then the same concept in terms of the AVL tree, but it's gonna, when it's moving the node, it's moving the entire thing. It's not just moving, oh, it's thing. It's moving the set. It's moving the center along with it. It's just really rotating the left and the right, but the center stays the same in the node. So that's, you know, that's the concept there in terms of the AVL rotation. Here, there is a thing in terms of adding node that I wanted to show you in terms of where this information is coming from. So where are you getting this information, the name and so on? You're getting it from here. You're finding AVL person, right? I'm gonna do a find AVL person, and that is gonna bring me that node. So when I find, actually load AVL person, so it's gonna load AVL person, and then here, so it loads AVL person, calls this code over here. That's gonna build this. That's gonna build this this tree, this binary tree, or this AVL tree. It's gonna build that, and then I want two persons inside of this node. Oh, that actually brings me to an interesting concept. See here, right? This is the thing. In this node, right? This is an interesting concept. In this node, I'm putting a person ID, a contact ID, or a PID, the CID, the first name and last name for the person doing the contacting, and then I'm doing the first and last name of the person being contacted. I want to improve on this eventually, and instead of putting the characteristics of the person, why not put an entire person? So instead of all of this here, right? Instead of all of this, I'll just have person 1 and person 2. That's it. Rather than having 6 different items to deal with. I'll push the items or extract the information, but in that node, there'll only be two persons. There's still only two persons here, but within the node, I want to put, I just want to name it two persons, person one and person two. So that's these two persons here, person one and person two, and it's gonna send that get client ID. That's this one here. So it's calling this code right here, get client ID here, and then it's returning that node. And then I'm going to take the information from inside of that node that person, wait, what am I doing here? Get client ID. Okay, I'm asking for the information. I'm asking for this set of information here. I want the node, the information that this node contains. Now what does this node contain? This node contains this information here. So I'm asking for this information. And what am I sending to get that information? I'm sending these two numbers here. I'm sending first this number, and then I'm sending this number. So PN is the first number and CN is the second number. So I'm passing that, getting the information, and then I'm going to push that information now into this here. And this particular operation here, this operation is O of log n because it's an AVL tree. I'm letting the program use its own AVL tree to find the information and load the information into a second set of nodes. In fact, into this set of nodes right here, right? And that's what creates that that new tree, and that new tree is going to, I'm not going to go through all this other codes because it's like basic stuff. I really just wanted you to see how cool this class really is, right? Once you get into building the class and then you build the tree. And then the concept really behind building, having the two people, breaking it down into simply two people, and then putting it back together, stripping the information down and then putting it back together in an efficient way that you can actually get your information displayed in this format. You know? Ooh, I didn't rebuild this thing. I still got the I am here code. And we'll add someone. Let's add someone. Let's add a contact. Let's first add a contact for, let's see all contacts again. 3, 2, Tim. What's Tim number? Tim is number, actually I could find it. I don't even need that. Here, look, I could just go back to this. I could just come back to this. I want to find Tim. Tim. There. So Tim is number 13. So I'm going to go back to my main menu. I'm going to go to contacts. I'm going to make a new contact. So Tim was 13, and let's say Kim came into contact. Tim came into contact with person 20. Okay, so now I'm going to show all contacts. And person 20 is Ollie. Okay, here. Person 20 is now under Tim. Anything other than this, I can guarantee you, in order to build this system using C++, I don't know that you can, I haven't, of all the different ways that I've thought of doing this, this is simply the best way that I could think of. So let's do 21, and 21 came in contact with 22. Let's do another trace. 21 came into contact with 22, and then let's do all. So 21 came into contact with 22. And I don't have to type the person's name over and over again. I don't have to type anything over and over again. All I need to do is type these two numbers in, and it's going to give me my information. I don't have to type the name, I don't have to type their addresses, I don't have to type anything. A person can have more than one addresses. And then, based on their addresses, you can then build on that and say, well, you can start looking at, excuse me, location. Where did the person go to? Who did this person, who did this person get in contact with there, or who was at that location, or you just make that data if you make it public. But then you'd have that, like I said, in the concept, you'd have validation, because you don't want people to have, you really don't want to have people making false information, giving false information. So you can do like 21, can, oops, not a valid choice. Let's do 2, do back 21, and 21 came in contact with, let's say 1, just for the point of this. Let's do this. 2 persons with the virus coming in contact with each other. It should work, you know. I mean, here, urinated came in contact with that person, and then now the reason it doesn't show up here, right, is because I'm only looking at it's not I haven't done it in reverse. Okay, that was one of the other things that I wanted to do, that I wanted to run it in reverse to see, well, okay, if the CID number, right, if this number here is equal, check to see if this number here exists over here, and then just interlink it. So like 21, so here I would create, I should be able, like, to improve on this, I should be able to, in the same way I have it here, is to come down, is to come down in the center of 1 and add 21 there as well. And that's something, if that's a need, if that's needed, you know. But I know why it doesn't show up on under this name here. But yeah, I mean, it was pretty cool. It's pretty cool. I basically built an entire SQL system out of CSV files. Can you imagine that? Let me know if anyone needs help with any of their codes, and we'll take a look at that. All right.